Well, hello everybody. Welcome back to day 2 of our virtual vendor summit for November of this year, 2022. Just a reminder, a couple reminders. One is we will have a survey for you to complete at the end of the summit that we'll be sharing the link to on IRC and Slack and in the Zoom chat. And I think we'll have it on a slide at the end of the summit as well. And also, please feel free to join us over in the hallway track in between talks. And after the summit is over, we might hang out and chat for there after this afternoon as well. With all that said, our first talk this morning is going to be from Hiroki Sato. So I'm going to hand it over to Hiroki.
Thank you. Can you hear me?
Yes.
Okay, so just a sec to make the screen available. Okay, so let's get started my presentation. I'm Hiroki Sato, the developer of FreeBSD and the board member, one of the board members of the FreeBSD Foundation. And today I will introduce activities and the market of FreeBSD in Japan as titled and shown on this slide. And I already uploaded this slide to the wiki page, so please see the PDF if you have difficulty with reading the slides via Zoom or streaming. Yeah, some sentences are written in the small letters, so please see the PDF instead. Okay. So I will talk about the two things. So one is yes, previously in Japan and with the market related to two topics. One is history and how the market looks like today. So to understand the use of FreeBSD in Japan, you need to understand the what people were involved in the Unix market in, say, that's 30 years ago and 40 years ago. So because the developers who are familiar with BSD is still in the big company in Japan, and they're doing the Unix related things or Linux related things because there are several reasons for them to change their job of the BSD related job to the non-BSD related job. So first half I will explain the such a background of BSD in Japan, and after that I have had learned. I have had many conversations with Japanese vendors in these, I think, over 10 years as a board member of the FreeBSD Foundation and as a committer of the FreeBSD or as just a user of the FreeBSD in the Japanese community. So throughout the communication with enterprise FreeBSD users, I have several ideas and I have stories that can be shared with you about my success and the failures. So I want to share such an experience for discussions. How do we do for do we do to improve the relationship with enterprise FreeBSD users, not only in Japan? Okay, so first of all, let me introduce myself first. I joined the FreeBSD project around 2000. After that, I served as a core team member after 2006, and for 16 years and 2020 until the 2022. And before joining the FreeBSD project as a committer, around the 1998, I joined the FreeBSD Japanese user group called Japan FreeBSD User Group on the middle on this slide. And they reproduced the same structure of the FreeBSD project. I mean, they have CVS tree, CVS repository, and for Japanese users, and they have committers to Japanese local CVS repository to get more people for the FreeBSD development or activities like a translation that cannot be imported to the main CVS tree directly. So proofreading or checking the build, checking the if it built successfully on the by using the local CVS repository. So after the 2 years, I joined the FreeBSD project, and my day job is an assistant professor at Tokyo Tech, and it is not closely related to the software technology. My research field covers integrated circuit and transistor level circuit and a much lower level than software. And I cover my research field covers the embedded system or operating system and around the boundary of the hardware and the software. Okay, so let me move on to the short history of the FreeBSD. And before the FreeBSD history, let me introduce the Japanese industry first. So this is not related to the FreeBSD, but you need to understand the start point of the Japanese industry. The first 60s to 70s, Japanese learned the microprocessor from the US, of course, the electrical circuit, the processors, and almost all of the concepts are imported to Japan in this time frame, just after the World War II. And the Japanese vendors started to develop the electronic calculator by using the microprocessor technology. In the same time frame in the US, most of the microprocessors were for military purpose or space industry, not in the consumer industry. However, in Japanese market, electric calculator was the driver of electronic device market, and it make the other related industry growing continuously. So in this era, we know what is the semiconductor, what the semiconductor is, and how to design the semiconductor and integrated circuit. And 10 years after, we started to try to design our own computer. Of course, the concept of a computer were imported from the US too. However, in 70s to 80s, we have knowledge about the semiconductor and the processors, and the Japanese government wants to build our own system. So DIPS is one of the famous national projects. The DIPS stands for the Denden Kosha Information Processing System. The Denden Kosha is a Japanese word that indicates company name, the government company name, and it means in English government company for telephone and telegraph. So this system was built for processing the telegraph automatically, and it has as of 1971, it has a multiprocessor capability, surprisingly, and it has 256 megabyte virtual memory address, and it is quite ambitious system, and actually developed, and the photo on the right-hand side shows the actual implementation and the hardware, and you can see in the museum in Tokyo. And the operating system was written in the University of Tokyo, and it called C-Tron OS within the PL1. So we know processor at this point. And this project is important because a lot of big electronic company in Japan, including the Hitachi, Toshiba, Fujitsu, these names, and they were involving this project to get knowledge and resources to develop the computer system. So after 80s, they started to use cell and the design and cell workstations for office automation. The DIPS was for telegraph automation system. That's special device and not available in the normal market. So they develop vendor-specific processor and the workstations for a normal consumer market. So two photos are shown on the lower side of the slides. The right-hand side one is the Sony's workstation. It is 30 years ago, and it was built with a Motorola 68,000, and later the architecture is switched with MIPS architecture. And the left-hand side shows the not so exciting photo, but it is one of the biggest workstation released by NEC called the EWS 4800 series, and it uses MIPS architecture. And operating systems for them are not domestic ones. So for DIPS, Japanese developed on OS independently from the Unix or other operating system. But for consumer market, we used the slightly modified version of the System 5 or BSD BSD itself, modified version of BSD. The reason why we did not develop our own OS independent from the Unix is the important point for consumer market or office automation was that we needed to localize the Unix OS. I localize the OSs. So we can develop the entire OSs, whole OSs. However, it required more costs and manpower. So we decided to use the existing performant OS and localized it instead. So Japanized operating systems were used on these workstations. And for office automation, as described, Japanese Japanese document processing or displaying Japanese is a quite essential functionality. Most of the Unix OS, the imported Unix OS, did not support the non-Latin based character handling, and there were no UTF-8 or Unicode at the time. So we need to build the character set, and we need to build the encoding. So that costs a lot to the vendors. However, we were using the Japanized version of Unix OSs. So in the case of Sony workstations, it was discontinued around 1998, but their OS, it is called the News OS, but it's just a Japanized version of the 4.2 BSD. And NEC adopt the System 5 release 4 at some point, but both these kind of systems were popular in 80s to mid 90s in Japan. So this means that there are a lot of developers who know BSD or Unix at this time frame in the Japanese market. And after that, late 90s, as you know, the PC software called the PC Unix emerged. It's the combination of the commodity hardware and Unix operating system compiled for such a hardware. Now, this combination became quite popular to build the internet service like the web server at the time. And in this time frame, the workstations, domestic workstations, disappeared because, excuse me, because PC Unix is much cheaper and enough in terms of the performance. So the market no longer required the workstations available in the 80s or 90s. So at around the 90s, so PC Unix emerged, the FreeBSD or Linux or NetBSD or so BSD derived operating system that can run on PC became quite popular. It was around 1995 to 2000. And I repeatedly emphasize that there were a lot of Japanese developers who knew BSD well in the companies like NEC or Sony. And at the same time, in this time frame, the PC Unix emerged. This means that normal people who are not in the company uh, can have a hardware that can run Unix operating system. So local community was formed. Local community, including the Japanese FreeBSD user group, was formed around 1996, I think. And after that, the activities were pretty pretty good, and it produced some notable results, including the Kamiya BB6. This is trying just an attempt to implement the full IPv6 stack by using the BSD and intended to use the BSD-based IPv6 stack for as a reference implementation. And so many Japanese other companies were involved in this project, and they use the FreeBSD as a foundation for designing their IPv6 capable system. And another one is POW project. POW project was for adding the support of the ACPI and the mobile device support. And its time frame in 1998 to 2004 to 2005, there are a lot of small gadgets in Japan, the battery-driven gadget and the hot plugging interface like PC card or FireWire or this kind of complex devices that FreeBSD did not have support. So local community had a lot of meetings, and some of the developers who knows FreeBSD well developed the code and test test with a lot of devices that are available in the Japanese market. And eventually, these results were upstreamed to the project. So these kind of activities are backed by the number of developers from the ancient era around the 80s and the 90s. So these community were driven by not by the young people and an experienced developer whose job was developing the BSD derived BSD based operating system for a big electronic company in Japan. However, at the same time, at the same time frame, at in 2000, big players in the Japanese industry, electronic device manufacturer, made announcement that declared that they would support Linux as their business foundation. That these announcements were made at not made at once, did not made at once and independently by each companies, but they have they had some kind of agreement at the time. That the reason why they declare this kind of announcement was that uh, at as of 2000, they no longer were interested in workstation industry or selling the operating system or developing their own implementation. And looking for software they can rely on and uh, uh, performant, sufficient for their purpose. And before 2000, so Linux appeared on a discussion of the uh, in a context of the open source, and a company using the open source will get uh, um, so better results due to the reducing the cost of developing the OS, whole OS inside the company. Well, this kind of story were popular just before the 2000, and these companies decided to use Linux. Of course, there were BSD derived operating system at the time, but uh, they were ignored just because this is not a disclosed. The reason was not disclosed, but one of the reasons was the lawsuit. As of the 1998, that was not settled, and the future of BSD was unclear to these companies. So Linux was only one a choice at the time. So this announcement has a big impact on the community and the people who were working on the BSD. After 2005, the FreeBSD user community, developer communities in Japan started to shrink because uh, education for new recruit of the big company were handled by these companies listed in the previous slide. So Hitachi or Toshiba or NEC or Fujitsu, they built an facility for education, and they use that facility uh, without restriction for the company's boundary because they need the education for Linux, uh, even if they are not in the same under the same umbrella. So they have single education system that teaches the Linux things as a new Linux education, and using Linux. So young people, on the skilled people hired by the big companies will have an education, this kind of education. So young people do not cannot know the other OSs after the declaration of the we will use Linux by the big companies. And at the same time, experienced developers went to the non-BSD business because their companies decide to use Linux, even for their internal mail server or web server. So everything must be on Linux. That is a decision, top-down decision of the big companies. So in the community, there is no longer a reason for even for the experienced developers to keep up with joining the community. So number of people are still um, decreasing, unfortunately. So the big companies still drive their adoption of Linux. So the developers cannot decide what technology is used for their business or for their purpose in the OS level. And it is difficult for the young people to know or learn the BSD. And the second half of this slide is listed my attempt to get more people in the community after 2004 to 2005. I started to hold the HBSDCon in 2007, and I held the 14 times over about 20 years. And I am keeping up with a monthly meetup in the Tokyo area, and now I've actually held in the FreeBSD workshop, and it is held in 91 times. And we have several Japanese forums because the language barrier is quite big. So we need forums or communication channel in Japanese. And maintaining this kind of channel, we know how many numbers actually interested in the FreeBSD in Japan. And the numbers are listed on this slide, and about the 1,000 to 2,000 in this order, we will get the social media. But almost all of the people are 14 years old, 50 years old, so developers in the 80s or 90s, or the old era. And 100 at the conferences, and 20 around the 20 at the monthly meetups. So based on this Japanese history, I will share the conversations with Japanese enterprise FreeBSD users so far. And BSD is becoming less popular in Japan, unfortunately, but there are users, still users in Japan, and I have a conversation with them. And throughout the activities to have a talk with them, I categorize their motivation, their needs, and how they feel about the FreeBSD. So this is a diagram. This slide shows the simple diagram. The rectangular means company. So it's the factory, the BBT, and I will show the details of each companies. But the rectangular represent the company, and the vertical axis means why they are using BSD. Top one is the factory has the passion. So they love FreeBSD. That's the reason why to use FreeBSD. And one of the companies at the bottom of this slide, so NEC or KDDI Web Communication, WC, they have a reason in their business. So because the customer is using the FreeBSD, so we need to prepare the FreeBSD or something like that. So the categorization is more specific categorization is listed on this slide. So far, conversations with vendors in Japan, I can categorize all of the conversation into 4 listed on this slide. First one is passion. Second one is inertia. Inertia sounds negative, but a lot of users said they are still using a FreeBSD because there is no reason to change. In the first place, they have some specific reason, but they have a lot of accumulated experience, accumulated software resource required for their business using the FreeBSD. So it is difficult to change the system. So that reflects the word no reason to change, but I think this can be categorized by using the word inertia. And the third one is superiority. In terms of performance, in terms of the usability, or there are a lot of specifics, but I think I can categorize them into the superiority because previously was the best in terms of something. And then last one is they have no choice and the customer decided everything. And in addition to the 4 categories, their use case can be classified into 2 types. One is they want complete POSIX compatible OS. Another is they want component in a FreeBSD. Component means they use kernel only or one of the kernel subsystems, or they are using just the libc only or header file only or userline utility, one userline utility. So after categorizing the use cases and the motivation, some comments from listed in the bottom lower side of the slide. For vendors who want the complete OS, information in Japanese or commercial support service they want are top items of their needs. And the second one, the component level views of the FreeBSD, they want a contact to ask a question or upstreaming their changes. So they need to know how to engage the project, or completely have no idea about engaging the project. So following slides shows the individual vendors, but it takes a long time, so I will pick up some sentences from these slides. So first one, in the Internet Initiative Japan, it is one of the largest ISP in Japan and categorized as the passion and the component. They love BSD, and actually they are using a NetBSD extensively, but a component level. They have their own development team that can understand the kernel level development, and they build the high performance router based on the NetBSD, as shown on the right hand side photo. And I have a good relationship with them, and they donate an AJBSDCon, and they understand how the open source project works and how important of the donation to the project or development activities. And the second one is Sakura Internet. This is normal internet service provider and hosting provider. You can imagine in your local market in a similar service, and this service offers the BSD system image for their hosting the service, and we can choose the FreeBSD and use the virtual server based on the FreeBSD. And the this company is categorized to the passion, and they want a complete OS that can run on the KVM, unfortunately. So they are running in the Linux on the bare metal and offering the FreeBSD based virtual private server on KVM. But the founder loves the FreeBSD. So this is the reason why they are still providing a FreeBSD, and this is categorized as a passion. And S2 factory, this is the top of this top floor, the previous slide. There's a fashion, but this company is small, but run by the two of the FreeBSD commuters and building the website. But they have a difficulty with using the FreeBSD as core OS for their purpose because the website technologies tends to be Linux centric. So sometimes FreeBSD does not able to is not able to do what they want. So some inertia is there, but they are still using the FreeBSD, and the complete OS is required. And connectivity web communications, and this is another type of ISPs, but this hosting provider is providing the FreeBSD only. The reason why they are using the FreeBSD is there are customers who want FreeBSD. For example, the quite old system running FreeBSD, say 7 release or the 8 release, they are still serving the 7 or 8 environment. But their business, one of the targets of their business is supporting such an old environment. Of course, it is on that they are running the FreeBSD on the virtual environment, but supporting the old FreeBSD systems are one of their core business, and they are currently providing a bunch of machines and network resources for Tier 1 mirror in Japan right now. And the broadband tower, it is written as a BBT in the previous slide, has a passion. This is a data center service provider. And I have a conversation with them, and head of the laboratory is one of the privacy lovers. So he want to donate something. However, there is no business relationship and there is no business needs in broadband tower, unfortunately. So I am contacting him and keeping up with a good relationship, but still wondering what should be what should we provide or what kind of relationship we have to maintain with it. But I got the donation of the machine resources. Okay, this is one thing probably you are interested in. So Sony Interactive Entertainment, it is a manufacturer of gaming console, and probably you know they are using the FreeBSD, and more specifically, they are using the FreeBSD kernel, 9.0 in the PlayStation 4 and 11.0 in the PlayStation 5. And they have development team in the Japan headquarters, and there are a lot of developers who are involving in the PlayStation development, but the decision making is made in Japan headquarters. And I have been discussing with the developers in Sony, and hopefully we can disclose the they are using the FreeBSD officially, and I want to build up the relationship between the internal development team and the FreeBSD project, say upstreaming the patches from their team to FreeBSD tree. But discussion was got stuck because they are too busy to handle the current release of the PlayStation 5. I am not sure you know the details of the development status, but the PlayStation 5 has several problems that, and the developing team still working on fixing the problem after the release. So to resume the discussion, we need some more time, but I will try to get them to engage the project. Okay, so let me summarize the lessons learned throughout the conversation. First, I tried to ask a donation of financial support, but it did not work. Especially in Asia, there are no business custom of the charity or donation. So they need some reason to support and fit under the business relationship. So we need to know what they want and what we can provide. And even in a quite small thing, such a relationship, without such a relationship, we cannot continue the discussion. So even if they love the FreeBSD, it is not so easy to build the business relationship. But after realizing this, I changed the strategy to have a conversation with the vendors, and I got a several donation of the machine resources instead of financial support or some other uh, uh, results after after the conversation. So lastly, these are one of my suggestions about how to promote the FreeBSD as a summary of what I talked in the previous slide. First one is users that think the FreeBSD has a complete performant OS, like the KDDI web communication. It is an old-fashioned internet service provider. We need to be aware of what middleware they are using, because they are not interested in the improvement of FreeBSD itself. They are interested in software running on FreeBSD. So they run flawlessly. They are satisfied. However, if some of the middleware doesn't run that doesn't run on FreeBSD, they are frustrated or consider to switch the OS. So we need to be aware of what middleware we want to support, or we should spend time or money more. And another type of users that thinks that FreeBSD as toolkit or reusable software component collection. So these users are using the specific part of the FreeBSD. It may be kernel, it may be a library only. So maybe it is not so high priority, but it is worth investing in improving reusability if possible. Reusability means, in this case, you can understand the reusability by reading the about list on the lower side of this slide. In FreeBSD, the RAM kernel, any kernel, is one of the good example to reuse the kernel on another system. And in OpenBSD, OpenSSH is a component, a reusable component. They say OpenSSH is a part of the OpenBSD, but the other people think the OpenSSH is an independent software. It is maintained in a portable way. And for FreeBSD, one of the examples is the OpenFastPath project. It is maintaining the FreeBSD network stack that can be used in the user land. This is one of the examples of the reusability of the software. And the last one is probably we need to be aware of the users thinks the FreeBSD as one can do something as Linux in a better way. So for that, it is difficult for us to make things in a perfect way, but the feature parity is one of the way and one of the things we can invest. Probably, of course, we cannot do everything and the limited resource and money or manpower. However, we are still be aware of these aspects for promoting FreeBSD. In all cases, I think we need to maintain a working example people can try easily as say system image they can try. And I call this FreeBSD showcase. We are providing a Windows image only and just installing the FreeBSD and people need to install the third-party software to build a system. However, if we are providing the as a complete POSIX OS or as a toolkit or as a Linux replacement, we can if we are providing specific system image for specific scenarios, people can understand how how useful the FreeBSD is or how much the FreeBSD is working sufficiently for their purpose. So I think these uh, things is what we should be aware of. So this is a last slide of this talk. Thanks for listening.
Thank you, Hiroki. That was very interesting. A lot of comments from folks on IRC that there's a lot of history that many of us didn't know. It was really neat to learn. I'm going to wait a couple minutes to see if anybody has any questions. I haven't seen any questions so far. Just a lot of positive comments on what you've talked about. So I don't see any questions, but I know we'll mention it later, but it is worth mentioning that you're planning to host Asia BSDCon again this year, I believe.
Yes, of course. And I'm sorry for the delay in making an announcement. And I will make an announcement in 24 hours. I will preparing.
Sounds good. Looking forward to it. Thank you, Hiroki. Okay. Well, thank you very much, Hiroki, for your talk. And we'll go ahead and take our first break of the day. For folks who want to, I'll be over in the hallway track and we can talk more about whatever comes up. And we'll be back here in about 25 minutes or so. So see you all in a bit. Okay, everyone, welcome back to the virtual FreeBSD Vendor Summit for November. So our next talk is going to be from James, who's going to be talking about the performance and scalability of ALTQ in FreeBSD. So I'll hand it over to James.
Okay, thank you. So let me make sure I do this right. I'm gonna share this screen and see if that works. Okay, there we go. Okay, thank you. As he said, I'm going to talk about parallelization of the hierarchical fair sharing algorithm within PF and ALTQ. And sorry, I got to get to the right screen here. So a little bit about me, just so you know who I am. I'm a professor of computer science at Kenyon College in Ohio. I have a somewhat long history working in BSD stuff and in networking and Wi-Fi. I was part of the team way back in the late 1990s and early 2000s that developed a Wi-Fi router product that we licensed to Lucent Technology in the Netherlands, and that became their residential gateway series, which was the first wireless router and the first Wi-Fi router. And then we basically that was then sold or licensed to Apple and became the Apple Airport back in, I guess it was late 1999, 2000. And then I have developed some other router products in the early 2000s and through the 2010s in NetBSD and in FreeBSD. And currently I've been working currently on my own on some improvements to the, performance improvements to FreeBSD. So that brings me to the topic. So ALTQ is a alternate queuing mechanism that's part of the PF architecture, the packet filter architecture in FreeBSD. And there is an algorithm, there's several algorithms within it. And one of them is the hierarchical fair service curve, which is developed at Carnegie Mellon, I don't know, about 20 years ago. And it's a very nice bandwidth shaping algorithm because it provides a rich set of features for hierarchically managing lots of users with lots of different rules, both in terms of bandwidth, burst bandwidth, real-time commitments, etc. And it allows you to group things into groups and subgroups within those, so that those groups share bandwidth fairly with each other. And so the idea is that you can have lots and lots of connections, and each connection gets a fair share of what the discipline says is appropriate, given the capability of the maximum available bandwidth. So anyway, so we end up with sort of a tree-like thing, and this is actually from the original seminal paper. So the bandwidths are fairly short, fairly slow, but the idea is that in the leaf nodes, there are users or connections, and they're sharing bandwidth of their parents, which are sharing bandwidth of their parents, all the way up to some actual physical interface. And it works really well. And I'm not going to talk any more about it, but it works very nicely. You can have hundreds, thousands, even tens of thousands of connections, and nobody gets starved, and everybody gets a reasonably equitable share based on the rules that you set up. The problem is ALTQ is ultimately single core, and the reason that is because the tree that we were just looking at, the way it works, there's a lock on the entire tree, and so and I'm going to talk about that, why that is. That forces all traffic to be serialized through a single core, and which isn't a problem with slow interfaces, but when you have 40 to 10 to 40 gigabit interfaces, you can't even get close to that. You might be able to get, 2 or 3 gigabytes in each direction, and that's it. Now, if you don't use ALTQ, some of you may know that the network stack has been parallelized, and RSS, receiver side scaling, has been added so that you can do full line speed network throughput through the kernel just fine, but you can't with ALTQ. So that's a problem. So, so I decided to look into that and see if that could be fixed. The other part of the problem is, what if you want to have a system with lots and lots of users? What's the point of scaling it to high throughput if you can't have a lot of users? So that's the other side of the thing of what I'm looking at, is how can we scale ALTQ to have 100,000 plus simultaneous users or streams, or user classes, because you could have the same user with multiple streams. How can you do that? And the second thing is can we get the bandwidth up to match modern interface speeds? So we're going to look at can we handle lots and lots of queues, lots and lots of users? And it turns out that right up front, there's a basic fundamental limit, because the queue ID, and you need a queue for every user class, was only 16 bits. So I had to increase that to 32 bits, which is enough for the foreseeable future, but we needed to do that to get past 65K. So the next problem is, under test conditions, I noted that when you have lots and lots of classes, it takes a really long time to load PFCTL. Now, that may not be a problem if you only have to do it once, but in a dynamic system, you may need to reload PFCTL, relatively a lot, because as the system dynamics change and you have more users, you may need to basically reload everything. Well, it turns out that it was really slow, and I looked in the code, and I'm going to show you how slow later, but it was, with 100,000 queues, it took many, many minutes to load a large set of queues. And so when I looked in there was basically what it was doing was, inside the kernel, it was, as it was adding the queues, it would add a queue to the end of a linked list. Then when it added the next queue, it would go to the end of the linked list and add it. And then it would go to the end of the linked list of that and add it. And we ended up with an n squared algorithm when we didn't need it. It didn't matter what order the queues were in. So I simply added it to the beginning of the queue, and we went from 120 seconds to load it to 5 seconds for 100,000 plus queues. And that was actually upstreamed into the official release this summer. The next thing I noticed was the parsing itself was taking a long time. And so I looked in the code, same problem in the parser. The parser was, every time it added a queue, it had to see, well, does this queue already exist? And it was traversing the queue to check to see if it already existed. Or every time it was adding a queue as a child, it has to find that queue, and it was traversing the whole list. So again, we had an n squared loop, and I got rid of that by adding a hash table into the parsing process, and that reduced the load time from 90 seconds to 10 seconds. And so these times, by the way, it was 120 seconds in the kernel, 90 seconds in the user land. And so I'm reducing time on both sides. And so we can see this here. Before I fixed this, in this case, it took 109 seconds. And I dropped that of user time in 108 seconds. of system time, and I reduced that to 36 seconds of user time and 5 seconds of user time. So significantly faster. Now, so that really helped. You don't do it a lot, but being able to do it this much faster was a significant benefit. Well, the next thing that you might want to do if you're running a system, if you're using this in real life, you might want to be able to collect the statistics and dynamically show which queues are pushing which amount of data. And the only way to do that is to gather the queue statistics. And the typical way of doing that is with the pfctl minus vsq command. Now, it turned out if you run that, say, with 100 or 1,000 queues, it comes back virtually instantly. But with 107,000 queues, it literally took 43 minutes to gather the statistics, which of course is ridiculous. And what makes it even worse is while you are gathering the statistics for that 43 minutes, the system throughput drops for some reason. I had to figure out why, and I'll tell you why, but the system throughput dropped from about, by 5 to 10 times slower. Okay, why is that? Well, what happens is the first thing it does when it wants to collect the stats, it iterates through all the queues to find out how many there are. Literally, it iterates through them just to count them. Then it goes back through and it says, I want the first one, and it counts to the first one. It wants the second one, it counts the first one and the second one. It wants the third one. And again, it's this n squared loop. And the big problem there is every time it wants to get a queue to pull the data out of it, it locks the queue, which creates a bottleneck for the kernel that's trying to pass data through those queues. And so not only does it take a long time, it slows your throughput. Totally unacceptable. So first thing I did was I thought, well, why do I need to iterate through all of these queues over and over again? So instead, what I did was I created an index of the queues on the first traversal, and then I don't have to iterate into, one at a time. I don't have to go through the list over and over again. And so that reduced the time of traversing the queues to get the statistics from n squared to n, but it still slows the throughput because you still have to lock each one of these nodes when you want to get the statistics out of them. So that was still problematic, okay? So it did help though, right? It helped quite a bit. In this case, we see that in the red here, we see that it took 43 minutes to get the queue stats out with 107,000 queues. And after it dropped to 4 minutes and 37 seconds, still unacceptably slow, but almost 10 times faster. So 5 minutes is still a lot. So I look back a little closer and I come up with another idea, and that is why do I actually need to do something to the queues, to lock the queues when I want to get the data out? And so what I did was I created a separate program to collect the data statistics, and I created a separate data structure to collect them in so that it would have no impact on the throughput. So I created a new program called ALTQ for ALTQ monitor to collect these statistics. And what I did then in the kernel was I created a list or an array of Q stats where each record was indexed by the QID, and it kept all of the Q statistics that we care about. And I'm only showing a few here: packets sent, bytes sent, packets dropped, queue length, etc. All of those are stored in this data structure as the system is running. There's virtually no cost for the kernel to update these, or very, very low cost, as it's passing traffic through. And then when I want to collect the statistics, I can just zip through this data structure, order in time, no locks. And I also made ALTQ instead of returning text, it returns either text or, whoops, sorry, messed up, or JSON, which I thought was a useful thing. Maybe not, but it does. I think it is. So this fast reporting of network statistics using ALTQ, remember, collecting using PFCTL using the existing method that slowed throughput and took a while, took 4 minutes and 37 seconds, which was a 9.5 times speed up. But when we use this new method, it drops it to less than a second, 0.11 seconds. So it was a remarkable speed up, right? So this ALTQ allows us to gather the Q stats virtually instantly with 100,000 Qs, and it scales. Okay, so that's sort of part one, getting the system to even work with lots and lots of Qs. Second problem is, can we increase the throughput beyond what we can push through a single core? And again, to sort of summarize the problem is a core cannot just physically cannot process packets at the same speed as new 10 and 100 gig interfaces, or maybe even what if you want to go to a 100 gig interface? Well, the problem is that the classes are stored in this potentially huge tree with one node per class. Each node contains a queue of waiting packets, and the children of each parent are stored as linked lists of siblings. So we have all these lists that we have to process. Every time an interface wants a packet, it has to go through this tree and figure out which packet has the best next release time. You know, and this is called the eligible list. Which packet is eligible to go, and which one deserves to get released next based on the queuing discipline. The only way to do that without having a race condition, because these linked lists are being changed all the time, is to lock the entire tree. And I actually spent a lot of time trying to see if I could only lock individual parts of the tree, and I failed. That just did not work. And so I had to try something different. So what I did was I basically parallelized the entire tree structure. I create multiple identical Q trees, one per transmit buffer. So this is an illustration. If I want to use 4 transmit queues, and we're not limited to 4, but if I want to have 4, I replicate the entire queues tree 4 times, and then I use receiver-side scaling to push streams randomly. I'm not going to get into all of the details of RSS in this talk, but RSS basically does a hash on various pieces of the packet header and pushes streams through various queues. Without parallelized ALTQ, RSS would just be pushing packets through different hardware queues directly. But I create these multiple trees in between RSS and the queues, and it works, okay? So RSS nicely balances the stream, and I'm not sure why it doesn't give us a full 4 times, but it gives us about 3 times the performance throughput when we use 4 trees. But there's a caveat. And the problem is, of course, when we have 4 trees, and if we have rules about, you know, maximum throughput per stream, not per stream, but per user. If a user is associated with a leaf node with a particular class, and let's say they're limited to a certain bandwidth, that's only going to work within a given tree. And if you have multiple Q trees, they're going to push multiple times the specified bandwidth. I'm going to show an example of this. So if you have 4 streams assigned to have 10 megabits upper limit Q, RSS is going to steer those into the different trees randomly. And if they all go to 4 separate trees, you know, that particular queue discipline is going to get 40 megabytes, which is 4 times what it deserves, right? So how do you fix that? Well, what I'm working on right now is something called a scoreboard. And the idea is that when I was already saving this information about throughput in the array for ALTQ, so I'm going to reuse that. And so what happens is I keep score of how much throughput is going through each tree on a per queue basis. And then what I can do is aggregate that data and add it to each of the other trees' computations. So each tree limits each user to the correct amount of throughput. Now, so how did I do that? Well, I added this local byte sent and a class pointer and a timestamp basically to each record for each queue. And then what happens is every 1/10 of a second, I try to reconcile the differences. In other words, if we have the same user, in this case, is pushing data through 4 different queues. It could be 4 streams, it could be 100 streams, however many streams that particular user is using, they're going to be using the 4 different trees. And it's not just a single class, because remember, this is hierarchical. So in this case, we have 4 inherited queue classes that we're going through. And what I do is I total up the throughput for each class in each tree and add it to all the other ones. So here I show this here. So this gets added into here, this gets added into here, this gets added into here, and the same is done to here. All of these 3 are added into the one on the left. All of the other 3 are added into this one. And I add that into the cumulative that I'm accounting for in the HFSC algorithm, and sure enough, it works. We get the correct amount of overall throughput across all of the separate trees. So, again, to review, by adding the data that is passed through the sisters to the CL total, this is a value within the HFSC algorithm. HFSC will consider the data passing through all of the sister trees, and we get the correct cumulative throughput. And by the way, haven't really talked about it, we also have to fix it the same way for the guaranteed rates. Guaranteed rates are when you basically provision a user and say you're guaranteed to have this throughput. You also have to adjust it for that. Now, I did notice when I did this that certain trees would get out of balance and there would be starvation. And so I fixed that by basically putting a lower limit on when I would add the values of the sisters in. And so basically, if anything was less than 1/4 of its 1/n, if you have n queues, I decided, well, I'm going to not limit that one and let it naturally rise back up. And then when it gets past that lower limit, it seemed to bring it back into balance. And so this seemed to work really well. I didn't see the starvation anymore. It appeared to push up the lower throughput queues and keep them in balance. Now, where are we at with all this? This works, but there's an issue. And here's the issue, and I'm still working on this. It's cache contention. Now, I won't go into a great deal of detail here, but what cache contention is when anytime a core accesses memory, and if it writes to that memory, if any of the other cores have cached values from that same memory, that cache is invalidated, which means that the next time they access that memory location, they have to reach through cache all the way down into main memory. Now, I did a lot of experiments with this, and it turns out that typically when you invalidate a cache on memory and you do it all the time, it slows processing by about 10 times, because cache memory is about 10 times as fast as the actual RAM. And so that's a real problem. And so I don't get as much throughput as I should because there's contention somewhere. And I've spent a lot of time looking at this, and I'm still looking at that. A couple of other issues are fair sharing is sort of modularized. I'm going to talk about that in a second. And then the third thing is burst mode. Burst mode is when you say, oh, a user can get 3 seconds at 3 times the normal rate. Well, it turns out you get a burst mode in each queue tree, which isn't really right, but it still works. It's just, not quite as advertised. What's the fair sharing balance? Let's say you have 3 users, 3 streams and 4 queues for a given user. Well, they're going to correctly be divided up into 33 megabits each. Works fine. If you get 4, they're going to be divided up into 25 megabits each. Works fine. Problem is if you have 5, you can't, RSS is only going to push each stream into one queue. And the way this is going to balance them out is it's going to say, I'm going to give 25 megabits per queue tree. And if, by the pigeonhole principle, if you have 5 streams and 4 queue trees, at least two of them are going to have to go through one queue, and that's going to divide the 25 that one's going to get between the two, and those individual streams are only going to get 12.5. This is probably not going to be noticeable by most people, but it is an issue. So I don't know where my time is at, and I don't have any idea if I went through in the right amount of time, but well, I guess I don't have to stop sharing. That's my talk. So do we have any questions?
Thank you. I'm looking to see, we don't have any in Zoom at the moment, but I'm going to go look on IRC to see if we have any there.
Okay. Oops. Yeah. Let's see. Okay, here it goes. Oh yeah, so we got 17 participants. Okay. So one thing I'll say while we're waiting for questions is this work is not 100% complete. As I said, I still need to figure out the cache contention issue it works, but it doesn't work well when I use the scoreboard because of cache condition ends up slowing down throughput. It would be interesting, and what I would like to do is upstream this if I solve that problems. And I have talked to people within the FreeBSD community. I'm not a member of the DevOps team, so I would need to work with somebody, and I'm interested in doing that.
So that was the main question, actually, that was on IRC, were your plans for upstreaming. I believe I saw you in Vienna, and I think you talked with Christoph quite a bit.
Yes,
about
I did.
this.
I did talk with Christoph quite a bit, yeah. And so, this is a project that I am interested in.
So beyond what you just mentioned with still trying to address your issues with the scoreboard, are there other plans you have for ALTQ beyond this? Or other areas you would like to work on?
Not, it's a good question. And I guess I've been so myopically almost focused on the scoreboard that I haven't really thought beyond that at this point. So, but bigger picture is I am interested in, this is sort of driven by, a perceived need for HFSC to be able to work in a situation where you have lots and lots of users. I think if this, this works, I think I've handled most of those. Now, this only works with HFSC. Should it work with RED or any of the other ones? That's another thing I could look at if there was interest. So I guess I'm driven by interest from the community. And so if people in the community are interested in this work or interested in, other related enhancements, I'm game to consider that.
That's pretty fair. I mean, a lot of development in FreeBSD is driven by interest, and by people in the community or people using FreeBSD. So that's pretty par for the course. I guess one other question we had is: are there other areas in FreeBSD outside of ALTQ that you've either looked at or considered looking at, or might be interesting to you?
I mean, I've done some work with VLANs, and the VLAN architecture for that's actually a really good point. The VLAN architecture for FreeBSD is pretty, is a pretty major piece of software, and it does create some slowdowns. And in fact, when I use this solution and I put if I have 100,000, or well, not even 100,000, let's say I have 1,000 different VLANs, I notice that most of my speed up goes away, and I have to believe that's because of either some sort of contention within the VLAN world, or overhead in the VLAN world, or some sort of problem between PF and ALTQ and VLAN. That is another issue. And so if you want to use this with VLANs, it's not as fast as I'd like it to be. I would be interested in looking in the VLAN world. I have in the Linux world, on a completely separate project, I developed I took a Raspberry Pi and wrote a platform to turn a Raspberry Pi into an enterprise-like wireless access point. Not like a home router, but an enterprise, a manageable, a controller managed solution where each user would get their own VLAN. And I couldn't really get it to work very well with the built-in VLANs within Linux. And I would guess that this would probably exist also with FreeBSD, because the host APD software that I was using to build this most requires a hardware help for VLANing from the Wi-Fi radio firmware. And it turns out that about 5 or 10 years ago, most modern hardware doesn't include, Wi-Fi hardware doesn't include VLAN support. And so what I did was I wrote my own VLANing bridge as a kernel module for Linux. I could do the same thing in ALTQ. I could do the same thing in FreeBSD and see how that, use that as an alternate VLAN, because it's a very lightweight VLAN solution, because it doesn't involve interfaces. It basically just passes the data through a bridge that does the VLAN tagging on the fly. And so it's very fast and very minimal in terms of CPU loading. So I don't know. So VLANing is another area. Yeah.
Okay, and then we have a question from Zoom from Delbert and Ken Murray. He's asked, do you have any plans to parallelize CODL or other similar ALTQ methods?
Yeah, that's a really good question, and I haven't really thought about it. To be honest with you, I haven't looked at those other disciplines at all. Again, if there was serious interest in that, I would invite, somebody to contact me, and I can look at that code. I really don't even know how that code works at this point. So I have, very little to say about it. I've really focused exclusively on the HFSC algorithm. So I'm not disinterested. I don't have a good answer at this point.
Okay, well, I think that's all the questions we have for now.
Mhm.
But thank you very much. It was a
Okay,
very interesting talk.
Yeah, I'm realizing now I designed this talk to be more of a half-hour talk, and so I think we ended earlier than I probably should. But
We're a few minutes early, but that's okay. Our schedule is pretty flexible, so it's
okay,
working out just fine.
okay,
Thank you very much, James.
sure. Thank you,
So
everyone, for listening, and feel free to email me also if you have any questions. I guess I didn't. I don't know if my email address is included anywhere else, but I'll put it on these slides. Is there someplace I should upload these slides to?
Actually, Anne will probably reach out to you and we can put it on the wiki page associated with the summit. Yes.
Okay. And so where is this at? Anyway, well, thank you, everyone. I'll stop.
Sure. Thank you, James. So now we'll take our next break. We'll be back in about 35 minutes or so, or maybe I guess it's 40 minutes for the schedule. We'll be back then. So folks can head over to the hallway track, and we'll see you in a little while. Back for our next talk. Thank you very much.
Thanks.
All right, everyone, welcome back. No, actually, make sure I don't leak audio from the hallway track. Welcome back from our break. Our next talk is going to be Jason from DeepStack talking about using FreeBSD in an enterprise environment. So I'm going to hand it over to Jason.
Awesome, John. Can you hear me okay?
Yep, looking good.
Great. Well, hope everyone had a wonderful break, and thanks so much for the time to speak to the group today. Super excited to share a topic that I'm very passionate about. Having been a FreeBSD user for, geez, probably going on 15, 16 years now. Much like many people, I started out as a hobbyist and found myself throughout the years working with various different operating systems and enterprise environments, mainly focused in the payment space. So DeepStack is a payment processing company. We do credit card ACH processing, and getting very frustrated with some of the other operating systems that we were working with because of all of the mysterious random error codes and black boxes and support tickets. And I had a colleague of mine in college that said, hey, you need to give FreeBSD a look and an opportunity. So I started playing around with it and absolutely fell in love with the simplicity of configuration and standardization of the operating system, and decided to build or rebuild our company at the time on top of the FreeBSD stack as an operating system. And we were very successful in doing that. We launched our entire product. This was back in 2008, not DeepStack, but a different company on top of FreeBSD, and continued to use that operating system in various companies and projects since that day. And one of the challenges that I've always run into with FreeBSD, especially dealing with regulated, banks and different organizations, and a lot of security standards, is it is not known by a lot of security standards as a enterprise grade operating system, even though it is fully capable of it. And I have spent countless hours over the years talking to auditors, InfoSec guys, CIOs, CISSPs on why we use FreeBSD in the enterprise environment and making that business case for it. So that's why when invited to speak with the group, I said, I think this is a perfect topic to discuss, because FreeBSD at its core is a tremendous operating system that is more than capable, and in some ways better than other operating systems when you're dealing in enterprise environments. So this is a topic I'm very passionate about. We have put our environment through countless audits from an info security standpoint, and have passed them with flying colors. And in a lot of cases, had to teach various auditing companies or assessment companies about FreeBSD, right? They've heard of Windows, they've heard of Unix, but I'm sorry, of Linux distros, but they never really had experience with FreeBSD before. So it's been a lot of fun. I hope that the takeaways from this session enable and arm some people that are utilizing FreeBSD in varying capacities across different industries, different types of organizations, that are faced with the challenge of explaining to somebody who is not familiar with FreeBSD why it should be classified and why it qualifies as a enterprise grade operating system that is capable of passing regulatory scrutiny. So let's first talk a little bit about our environment. I think this will kind of set the stage for just the complexity of it. As I said, we're in the payments processing space. We deal with millions of credit card numbers, account numbers that all require, extreme security and protection. A data breach is something that would be insanely bad for us, and we go through extensive lengths and penetration testing, vulnerability management against our environment on a daily basis, as a matter of fact, to keep it as rock solid as possible. Today, we currently have close to 60 servers across 2 different data centers in the United States. That environment is active. We have our own IPv4 block that we anycast. I think we are probably one of few payments technology companies that actually anycast the platform, so that you're always connecting to the lowest hop. And within that environment, there are several VLANs that are all segmented. There's massive segmentation in our environment to isolate areas of the infrastructure where unencrypted cardholder data exists in memory, and also make sure that the even the encrypted cardholder data that is persisted to files is stored in a highly secured and audited way. So we're not just concerned about preventing some sort of attack, but also in the event that somebody were able to compromise an environment, that we have the necessary auditing, logging, and forensics in place for business continuity, disaster recovery, and incident response. So there's a few areas that I'm going to focus on that I think are the most common questions that I see when talking to auditors, assessors, and security folks that are not familiar with FreeBSD when you're trying to make a business justification for using FreeBSD in the enterprise environment. The first is security and stability, followed by high availability, patching, configuration management, and compliance. So let's start with security and stability. One of the things that I think is the most incredible thing about using FreeBSD and most of the products that go along or are installed on FreeBSD is they're all open source. And there's to some degree, a stigma against open source in the enterprise environment. And I think it's very unfounded for 2 reasons. One, working with open source software eliminates all the black boxes. There's no mysteries on how things work. You can always look at it, understand the code, dig all the way down the rabbit hole, and see what's going on under the hood. And secondly, and I think more importantly than closed source type solutions, when a product is open source and the source code is available, it's much easier to develop exploits for it. There's a lot more eyes on it. Things tend to be found and patched much quicker than closed source, where it's kind of a black box and a very small group of people know how it actually functions and what's happening under the hood. Secondly, I have never seen an operating system that has more of a consistent behavior from release and patch cycle to release and patch cycle. We have all, working with other operating systems, you install an update and all of a sudden a whole bunch of tools no longer work because some underlying library changed. The beauty of FreeBSD, the ports collection, the package management system is every time you're upgrading your software, you're upgrading the operating system. It's very easy to rebuild everything against that new operating system and not deal with things that are constantly breaking. Another huge advantage, and this is in a lot of security control or a lot of security frameworks, is making sure that what's running on the system is only critical things that need to be running on the system. And I love the fact that FreeBSD, the base install, has a very minimal set of services that are enabled and that are exposed to the outside world. And I'm seeing a couple of questions come in. I'll tackle those at the end, but as many of them as I can in a live fashion. So feel free to keep sending them in. So yeah, minimum base install. It rather than installing an operating system and having to deconfigure a whole bunch of services, FreeBSD out of the box. It's very easy to add on what you need and not have to worry about uninstalling or disabling a whole bunch of services. Additionally, it's very easy to tune, right? The syscontrol settings allow you to tune just about every aspect of how the network stacks run, how intrusion detection runs. It's very well documented. It's very frustrating trying to figure out how to change a specific behavior of the operating system. And I think a lot of closed sourced operating systems, they have all of these magic, settings that you can go apply that are very poorly documented, and most of the time you find out about them because some support person gave somebody in a ticket, oh, go do this thing. And nobody really knows what that thing does. With FreeBSD, that's entirely demystified, very easy to configure and tune, and very well documented. Next is performance. I saw a sequence diagram once, and I think it wasn't FreeBSD, but I think it was Apache versus a commercial web server, and just the sheer number of calls that are happening under the hood, right, in order to serve up a single web page. And I think this parlays on the open source factor, right? In that diagram, the closed source product that had a tremendous amount of code that just kind of lingered around forever, had two to three more times calls back to kernel libraries, disk IO, memory IO, than that open source Apache library. And I think that, that's just the nature of developers, right? We're very concerned about performance. We're very concerned about things running as efficiently as possible. And I think as a derivative of FreeBSD being an open source operating system, you have much better performance, and you can get the significantly more bang for the buck out of the hardware with FreeBSD than you can with other types of operating systems. And I think lastly, on the security and stability thread, one of the things that I think is very, very well organized, which makes compliance and regulatory audits very easy to tackle, is the separation between the base operating system and the additional software that is installed on that operating system. I think in many operating systems, those things get very intertwined. And the fact that within FreeBSD, everything that you're installing for the most part is landing in user local as opposed to part of the base operating system makes it very easy to separate what's part of the operating system and what's installed as a add-on library. So moving on to high availability. This is something that I have never been able to achieve with another operating system without having to go out and purchase very expensive firewalls and routing equipment. And just as a precursor, even our firewalls within our environment are FreeBSD, running PF, CARP, PF sync, and PF log. So we have built, like I said, an active multi-homed, any-casted platform utilizing pretty much out-of-the-box FreeBSD. We're utilizing CARP on the internal interfaces to, move IP addresses between firewalls, right? Each site has multiple firewalls. PF sync to keep all of that state synchronized between the firewalls. PF is the actual firewall engine. And the only third-party application that we had to add in order to achieve that high availability configuration was Bird, which we're using for BGP session management, right? For the IPv4 block that we have. So some interesting statistics. The current DeepStack platform was launched about 2 years ago at this point. We have had 0 downtime since inception, since going live with the platform. And the current configuration, we have load tested to 20,000 concurrent credit card transactions. And that didn't even push the platform to its limits. So, you know, with very simple hardware and very simple configuration, we were able to achieve massive high availability and fault tolerance out of the box. Patching. This is one of my favorite topics to talk about, and it is probably one of the most compelling reasons to use FreeBSD in an enterprise environment. One of the questions that I get all the time, and this particularly pertains to firewalls, is, you know, what you're using FreeBSD as your operating system for, you know, running a firewall. And I'm like, yeah, absolutely. And I think a lot of auditing and assessment firms, a lot of CISSPs, you know, they're used to seeing the brand names out there. And, you know, not to devalue any of the brand names, but here's my perspective on it. One, I think a lot of the major names out there are actually using open source tools, FreeBSD, other open source operating systems, and PF under the hood, right? They have just wrapped it up, put their own logo on it, built their own UI, but under their hood, it's the same thing that we're doing by hand today. And I'm not a big fan of, you know, of user interfaces. We'll get into that a little bit further in the configuration side of things. But what I have seen historically, especially being in the payment processing space, and like I said, we are doing vulnerability scans on a nightly basis. We make extensive use of tools like Package Audit, right, which is looking for CVEs in known or in installed packages. Is every time we see a vulnerability that pops up, we have a patch for it before most of the big name vendors do, right? A lot of the big name vendors that are relying on OpenSSL under the hood, in order for somebody to patch that firewall appliance, they have to wait for the vendor to create a new firmware update, download it, install it on their firewall appliance, right? Within our environment, we've set up a Poudre build server, which every night automatically goes and takes all of the packages that we have installed, downloads the source, and rebuilds it. So most of the time when a vulnerability pops up, we already have a freshly built build for whatever piece of software that is that's already patched. And we're actually quicker in getting those security vulnerabilities patched and mitigated than a lot of the big names are out there. Configuration management, another huge topic. I talked about how I hate user interfaces for configuration. Nobody likes the mysterious checkbox, right? What is it actually doing under the hood? I look at tools like PF and a lot of the configuration tools that are built on top of it that are, you know, WYSIWYG converting a UI back to a flat file. I love the beauty and simplicity of configuring FreeBSD and configuring everything that you install on top of it. Everything is flat files. You don't have to log into or use user interfaces to configure and make changes. And that creates a very, very powerful argument when it comes to configuration management. Just about every auditing and security assessment framework requires that you have some sort of change management process in place. And when you're dealing with file-based configuration, that becomes very simple in that you can diff those configuration files. You can use version control on those configuration files. And it almost inherently builds a change management process into how you're managing configuration. And if you want to take it a step further, we live and die by salt stack here. There is not a single configuration file on any server in our entire environment that is hand-tuned, hand-controlled. Everything is done via salt stack. That entire salt stack state table and repository is all managed by Git. It makes it very easy to track configuration and change management around the entire environment, have it in a single centralized repository. And I apologize, my slides are changing on one screen and not changing on another screen. That a single configuration repository and have a audit trail of every change that has ever been implemented on any production system. So last, I want to talk a little bit about compliance frameworks. These are two of the compliance frameworks that we deal with on a regular basis. And a lot of these frameworks, if you look at the controls, I think are very Windows centric. And a lot of the assessors who are doing the assessments on these controls are very familiar with Windows. And that has always been a big learning curve when you're trying to undergo a assessment, a PCI level 1 audit, a NIST cybersecurity framework audit. And a lot of the controls are written around Active Directory, right? FreeBSD does not have obviously Active Directory, right? The configuration is done very differently. So I think the topics that we discussed so far are the main topics that come up when you're going through a, for example, a PCI assessment, and somebody that is not familiar with the FreeBSD operating system, with how it's configured, with how security happens. And if anyone is going through one of these types of assessments or plans to go through one of them, feel free to reach out to me. I can refer a couple of vendors that we have previously worked with that are now familiar with FreeBSD. But I will tell you, if you find a vendor, if you find a partner on the compliance side of things, that you go through the process of doing things on FreeBSD with, that first audit, that first assessment may be more painful than future ones if they're not familiar with the operating system. But I've yet to have a security assessor that has gone through a FreeBSD assessment with us that at the end of that course does not think it is probably one of the most amazing operating systems from a security, compliance, patch management, configuration management perspective. It makes bundling everything up for the assessment very easy to catalog, to evidence, to keep together. And when you're talking about dealing with a enterprise operating system, getting through an audit, getting through an assessment around it is really, at the end of the day, what quantifies that operating system being enterprise ready. And we've done it several times. it is significantly easier when you're working with an auditor or an assessor that understands FreeBSD than just about every other operating system that I've ever worked with. So that is my case for FreeBSD in an enterprise environment. I'm going to jump over to the Q&A. First question I have is, can you share some of your notes on getting FreeBSD through third-party audits? I'm mostly interested on how to explain real-world security to checkbox compliance folks. Example, having split root passwords instead of disabling root passwords, disabling password logging completely. So great question. We've come up with a very interesting solution to this. And the way that we've done it is we've made our entire environment passwordless. Just about every security framework, or let me rephrase that. We've made it known passwordless. Just about every security framework today requires some sort of multi-factor authentication. And then there's a whole plethora of controls around password complexity, password expiration, not using the same password, within a certain period of time. Our solution to that is we have no standard passwords. We have implemented time-based one-time passwords on FreeBSD. There's a very nice plugin for PAM that supports it. And effectively, it works, just like you can use Authy or Google Authenticator or any type of application that, you scan the QR code, it lets you use a one-time password. So, our answer is passwords expire every 30 seconds. They're derived off of a secret that nobody knows off the top of their head. And in conjunction with the TOTP based password, we also use MFA, right? And that second part of the MFA is public-private key authentication. So the combination of something you have, the private key, and something which is effectively the password or the one-time password generated from the authentication app, satisfies all of the controls around passwords and MFA that we have ever run into from a security and compliance type audit.
So I actually have a question for you, Jason. I'm aware of at least one other payments processor that uses FreeBSD, Modirum in Europe. And I'm curious, in your experience, if you've run into any other processors that also use FreeBSD.
As far as I know, through my network, we are the only ones that are using FreeBSD holistically, meaning that every piece of our environment, top to bottom, is FreeBSD as the operating system. There's absolutely not a single server that is running any other OS or any other type of appliance. I know quite a few that use it from a development perspective, but development perspective in development environments, but have not been able to get the buy-in from leadership on using it from a production perspective. And it usually boils down to a lot of the unfamiliarity with the operating system in an enterprise capacity, and a lot of the types of points that we've talked about today.
Okay, we have another question in Zoom. Someone asked, how do you enforce the 4 I's principle technically and procedurally?
So 4 I's principle, and just for anyone who's not aware, it basically means that, for any action that's being taken, that there's two individuals that approve the same action before it can be taken. So the way that we enforce that from a configuration operating system perspective is one, we run so nobody has root access to any of our servers to begin with, right? You're logging in as a user account, and the privilege escalation, right? We use sudo once again with a PAM plugin and one-time password that acts as a we'll call it a break glass type of thing, right? So anytime that process happens, it's sending out alerts to everybody that is part of the InfoSec team, so that there is awareness that somebody effectively used the break glass logins, and those exist in case there's a systemic failure and the automated tools that are in place are down, don't work, something goes wrong. Outside of that break glass procedure, which I would say the 4 eyes principle is retroactive, not proactive, everything is controlled by SALT. And SALT is responsible for deploying configuration changes to all of the servers. The way we implement the, we'll call it the separation of duties, is through the Git repositories. And anytime any change is going to be made, a branch is made off of that SALT stack repository that maintains all of the states, and we're an Atlassian shop, so we make heavy use of the Atlassian products. A Jira ticket gets created. That ticket is approved by a senior system admin or by myself. The change is implemented, tested in a development environment. All of those tests are artifact, and then a pull request gets created from that branch back to the master branch that requires multiple approvers. That branch can't be merged into the master branch, which is ultimately how we have SALT configured, right? So we use getfs in gitfs in SALT to pull that configuration from the master branch, and that feature branch or hotfix branch cannot be merged into the master branch without multiple approvers, and that workflow is configured via the Bitbucket controls.
Well, thanks, Jason. I don't see any other questions, so I think thank you very much for your talk. Very interesting to hear. Oh, I guess we've got another question that just snuck in here, which is they're saying, do you use the Mac subsystem, the kernel? And I think what they mean is, do you use any modules that make use of Mac? I'm trying to think of ones that might be applicable. I'm not sure if there are any that you might find interesting, but do you use any perhaps like kernel modules that do security checks for you?
So we use a bunch of kernel modules, and I will, if you give me a second here, I will pull up the list of what we're using, because I do not know them off the top of my head. And I'm not sure which ones of these tie to Mac or not, but I'll just kind of go through them. So we're using the TCP rack module. We're using CryptoDev, the ACCF, HTTP, and data modules. And then I know on the firewalls, we're using obviously CARP and the TCP MD5 modules.
Okay, I don't think any of those are rack or Mac related, but that's interesting that you're using the rack stack. That's one of that's worked on by Netflix. Did y'all
Yeah.
find specific use cases where rack works better for you than the default stack?
Overall performance, and this is in conjunction with a whole bunch of syscontrol tunables. We're getting better performance using the rack stack.
Okay, that's very cool. I'll give another minute just in case we have any more questions sneak in. That last one.
I was thinking about stuff like see other UUIDs.
Oh. So these are different Mac modules that you can configure. I guess Biba and MLS are ones that are familiar to folks who've done. I mean, I'm less familiar with them, but they're used in some contexts, like MLS is multi-level security. See other UIDs is a way to hide like processes running as different UIDs from each other, I think. But it may I don't know.
Yeah, I know we have processes hidden. I'm not familiar with the other two modules. Our production environment is very well segmented, meaning that every server only has a single function. So we're not running multiple service daemons on the same on the same server. And the reason for that is, if there was a compromise at a certain layer, you're trying to limit that compromise and what it would have access to. So based on the fact that no server is running multiple services or that are being exposed, we've never really dug into isolating services from other services, other than we don't run any services unless absolutely necessary under the root user, right? There's a separate user that's created that once the application starts up, it's CH rooted to that particular user as opposed to running under root.
Okay, I do think some of these modules are kind of, they're focused on if you're running concurrent services, how do you isolate them from each other? So, yeah, I think they may be relevant for the way you're doing your separation, which is totally fine. One other question I had from one of our chat channels is, are you looking to hire any FreeBSD developers?
We actually just found and recruited a superstar FreeBSD developer not too long ago. So not currently, but we may be in the near future. So feel free to shoot over contact information and certainly reach out if and when the time comes.
Okay, and then we have another question on Zoom. I think they're asking, what qualifies as a security boundary for you? Is that just different real hardware, a hypervisor, or a jail?
So, couple things. And it depends on, there's a couple different ways to look at security, right? So our network is segmented based on different types of services. There's services that are publicly available. And when I say publicly, they're still behind the firewall. For example, Apache, Bind, Postfix, that there's a direct path from the outside world to the inside world. That is on its own VLAN. Every one of those services is running on its own dedicated server. We are not making use of jails today. I did previously at a past company, and they worked tremendously well. At the time that we were utilizing the jail system, it was a little bit more of a bootstrapped operation where we couldn't just go buy whatever hardware that we needed or whatever virtual environments that we needed. Additionally, so on top of that, there's VLAN segmentation between different layers of security. So system management runs in its own VLAN, public facing services runs in its own VLAN, what we call the cardholder data environment, which is anywhere that cardholder data exists in transit or is persisted, is in its own VLAN. And then every one of those services is running on its own hardware, its own server. We're not using hypervisors internally today. I have certainly made the and if anyone runs into this, feel free to reach out to me. I've certainly made the argument with PCI security assessors that you can segment the guest OS from the host OS through a variety of different settings. And we not for this project, but for a prior project, we were able to get through a PCI audit running inside of a virtualized environment, where that virtualized environment was not PCI compliant based on disabling, console access, putting in a boot password, using Jelly, disk encryption on the file system, so that if somebody from the host and the host OS, there was a compromise there, it would not directly lead to a compromise of the guest OS. The one thing that you can't really solve for unless you know how the hypervisor is configured is the memory encrypted. That's kind of the one sticking point, but there you start looking at the attack vector and how many how much sensitive data is actually in memory at any given time, and what type of exposure could happen if the host OS was compromised. How significant is it? So it's that is certainly a gray area. But I have been able to argue the point and get it past the assessors in the past.
Okay, well, thank you very much, Jason, for your talk and all the questions and follow-up and answering lots of folks' questions. Thank you again. And we're going to go ahead and take our last break of the day, and we'll come back for our last talk. So we'll see you
Awesome.
all. We'll be over in the hallway track if folks want to hang out, and we'll be back in about 30 minutes. Okay, everyone, welcome back for our final talk for this year's Virtual Vendor Summit. We have Peter from Ampere here to talk about FreeBSD and using FreeBSD in Oracle's cloud. So I'll hand it over to Peter.
Hey, everybody. Thanks for having me. Appreciate the time to talk about this stuff. Let me see if I can get my slides up real quick. Screen share. It's going to be a pain in the butt, apparently. Oop, I'm going to have to quit and rejoin Zoom to let my screen share. I'll be right back.
No worries, we'll wait.
All right, let's try this again. Here we go. And of course, I can't see the button to start slideshow. All right. All right.
Looks
Thank
good.
you. I'm good. Can you see that? If you can, then we're having a party.
Yep, looks good.
Awesome. So my name's Peter Pouliot, as was mentioned. I'm from Ampere Computing. We're a cloud native processor company. And I have Ed, I guess, joining me as well. What I'd like to talk about today is a little bit about the timeline for FreeBSD cloud enablement, specifically in terms of OCI. Give you a little information upon the chipsets that we have enabled in OCI, specifically the Ampere Ultra. Talk about our instances that are available for development, and a little bit about the free tier that Oracle provides for developers to have access, because it's a little different than the rest. And then give you a demo of using FreeBSD in Oracle's cloud via Terraform. So, and then after that, we'll have some questions and answers and some links that you guys can peruse to. So, yeah, I guess we can say, I guess it started in 2020 with FreeBSD promoting AR64 to tier 1 status. And essentially, you know, that adds another kind of a stronger level of support from the community around those images and production of those images and curation of those images, and ensuring that there'll be a standard kind of release pipeline around that. And over the last couple of years, we've been the team has been essentially working with the folks at Oracle to get images into the cloud, as well as to validate those images on the Ampere A1 instances that are available. In 2022, so this year, the 13.1 release became available in the OCI marketplace. So kind of as a nice flag in the ground. And it currently, going forward, they're working on providing support for bare metal instances in Oracle's cloud as well. So I mentioned free tier. Obviously, you know, we're talking about install media, binary packages, as well as, you know, interface stability. And in this case, cloud images, right? Making sure that we have curated up-to-date cloud images in native cloud providers, marketplaces. And also security updates and a curation process of CI and test kind of behind all that. I went too far. So this year we donated a couple new platforms to the FreeBSD Foundation to help use and help developers work on. What you're looking at there is one of our I believe it is a Mount Collins platform that we have one on Ed's desk, and one is racked in a rack, and some a pretty view of all the sexy cores that are now available for development on, and for you guys to play with. So the platform there has I believe 160 cores across two sockets. So one of the things with Ampere is we have the highest core density in the industry. So it can basically give you a lot of compute power in a small, dense form factor, which is pretty nice. So I'll talk a little bit about Ampere. Our mission as a company is to be the leader in cloud native compute platforms, and we do it by delivering innovation, performance, and value at a pace where that customers need. I've been at Ampere for 3.5 years. Our primary focus in the beginning was solely on providing high density compute for cloud providers, and what we've realized is we have a great processor that's capable of essentially helping people reduce their carbon footprint in their data center while increasing their real estate and increasing their compute capacity. So we like to call it the first cloud native processor. We started using that terminology when we first came into the market, and specifically we look at it from the perspective of when we architected the chips, looking to meet the needs of the cloud providers. So what that means in our case is we have a single thread per core. We have lots of cores, and we use a lot less electricity than our competitors. We currently have 2 chips in the market: an 80 core, which is what is found in the Mount Collins platforms that I mentioned, and 128 core. And the key difference of those, primarily that one is a little more suited for high performance. The 80 core has a couple extra layers of additional cache, and the 128 core is for higher density, but they are socket compatible. So for those of you used to using legacy processors, you'll be able to you could potentially swap out those chips. So one of the fundamental things that Ampere is really proud of is our efficiency of our platforms, right? So currently, if you're using x86 and you're looking to grow your existing data center footprint, you're going to be looking at a 2x increase of server power and a 1.6 times increase of real estate needed to house that compute. Whereas by using Ampere's processors, we can actually reduce the amount of power you consume, and while also decreasing the amount of real estate space needed to house that. So we like to say we have industry-leading performance, industry-leading power efficiency, and we also do a lot of work through open standards. So we do a lot of work with open firmware on our platforms. So as another example, HP recently started shipping one of their servers, the ProLiant RL300, with our chip in it, and that's one of the first enterprise platforms to ship with OpenBMC as an option. So we're really proud of that sort of stuff. So and obviously because we have a single thread per core and lots of cores, the performance for a lot of the standard cloud native workloads is increased. So as you can see here, we have like a 3.8% increase for web services like Nginx. We have basically we're consistent and predictable because our cores have a pin frequency. So when you're hyper-threading, you get fluctuation in the frequency of the cores, whereas ours it's pinned at a consistent 3 gigahertz. So that way you can assure that you're always getting 3 gigahertz, even for in the case of a cloud provider when it's being cut up. Because we have so many cores, we have unprecedented linear scalability. So for certain workloads, they won't even take advantage of all the cores. Obviously, our low power consumption comparatively to an Intel Xeon, we use roughly half the electricity. So the TDP of our Ultra and Ultra Max is 250, where the TDP of the high-end Xeon is about 500. So you can imagine that can when you're nickel and diming in your data center for compute power, it's you know, somewhere where you can reclaim some extra watts. And obviously, you know, talking about the just sheer density, you know, when you're dealing with legacy processor architectures, you know, and I've been in this situation myself, where you've had to basically remove capacity from the racks to be able to have enough power and enough cooling in the rack to be suitable for the operation of those servers. Whereas based on our power envelope and our heat envelope, as well as our compute density, we can get a lot more compute power in the rack than our competition. So, as I mentioned, we'll be talking about a little bit about Oracle's cloud. Now, Oracle's a little bit new to the cloud game. They have a phenomenal free tier, which basically has a bunch of services that you can get that are always free all the time. The big one that I'm a big fan of is they give you the ability to have 4 cores and 24 gigs of memory of Ampere's A1 compute instances, so that you can cut up in any way you want. So I use it all the time for a development environment because it actually works really well. And essentially, with that much compute, you can usually do what you need to do and prototype and figure stuff out relatively quickly and easily without having to accrue additional costs. So, and there's a bunch of other things that are available, and there's, as I said, other free services that are available for open source projects as well through the ARM Accelerator program. So here's a screenshot of the FreeBSD in the OCI marketplace. So that was to me it was a big deal for us at Ampere because you know, obviously we want to have parity from an operating system perspective, and I've been a big fan of BSD for most of my career. So having FreeBSD as one of the first extra options available for Ampere platforms was a pretty exciting thing for me. So that's what it looks like if you go to see it in the marketplace. And then what I'm going to show you next is essentially some Terraform that I wrote a while back. It's a Terraform module that it utilizes the OCI Always free tier to essentially get a combination of instances. It will create all the necessary network infrastructure needed to launch those instances and provide remote access to them. It'll also dynamically creates SSH keys and other needed things that will be needed for accessing the instance. It'll actually, we also pass in a Cloud Init metadata file to tell it to do some things on the first boot of that instance. There's been some work by the FreeBSD team and Dave Kaltenberg essentially to help enable that functionality. So essentially you get parity with Linux instances in terms of being able to ingest metadata. And then, as I said, we're going to launch the A1 instances using the latest curated FreeBSD image that's found in the marketplace. So I have some Terraform code that will actually detect what that is and look at it, and then we'll expose the instance to the outside world so we can SSH into it. So right now, what I'm going to do is I'm going to stop and share my other screen, although I think I might be able to do it from here. All right. So, I'm going to kill that because I had already pre-typed the command. So what I'm first going to do is initialize the Terraform repository. And that's just going to ensure that we have all the necessary plugins needed. And then very quickly, I'll show you too what the code looks like. So this is because I'm just utilizing a module that I created. This is the what the actual code I'm using to instantiate it looks like. We're pulling it from a source module located here. And then I actually do a little abstraction of the operating system selection. So I'm just able to pass in FreeBSD as a string to tell it to use FreeBSD. And then we're going to pass in some metadata. So this is just simple metadata file that we're going to use, install some packages, tell it to update itself, add a user and add a group with that user in it, and then echo a phrase into the MOTD. So to keep it simple, I'm just gonna basically the Terraform workflow. It's pretty, for those who haven't used it, it's pretty simple. You first run a Terraform init, as I just did previously, to initialize. Then that follows by a Terraform plan, which essentially goes through the code and ensures that it can perform the tasks in the order at which the tasks and it discovers the order at which the tasks need to be applied. And then essentially once that's done, we run a Terraform apply, which will actually go ahead and instantiate the instances. So I'm going to do this all at the same time using that string that I have right there. So here's the initialization. And now it's going to start computing what the plan is going to be. And then so this is the output of the plan. And then once the plan's done, it executes it via the Terraform apply. So this is the actual execution occurring right now. And as you can see, it's creating the subnets. And hopefully the demo gods are going to smile on me nicely. It's creating a local SSH key for me to utilize to get into the instance. And it's starting to create the instance. Now I have found once the instance is created, it will take a minute or about a minute before we can log in. So that is the external IP address that we're going to use. And I'm going to use the newly generated key to get into that. The user I'm going to use is just a user called FreeBSD. I'm just going to wait another minute or a few more seconds to give it some time to come up, because I found that it does take a moment. Yeah, still going to wait. But basically, this is the same experience that you would have on, other API-driven clouds. Launching instances, passing in metadata via Cloud Init, and being able to access them later through an external IP. There we go. And we're in. So as just to show the execution of the cloud init. So it's currently, I believe, doing the upgrade of the packages on the system as part of, as I told it to do via the metadata file. So this is part of the log output of that processing happening. Now, if we wanted to kind of end this, what I'll do, I'll show you how to destroy the instance. So essentially, I logged out. And then from a Terraform perspective, it's as simple as typing Terraform destroy. And then I'm going to auto approve of that. So I don't have to confirm it later. And now when I type this, it will remove any artifact that Terraform created during the run. So the SSH keys that I had dynamically created, it'll remove all the instances, well, the instance that I had created. And it'll also remove all the networking and all the other pieces that were instantiated during the Terraform run. I'm a big fan of this because from a work, like basically a workflow, it allows you to, you know, try something and remove it as though it never existed in the first place, which is key for cloud operations, because you could always have some little stranded artifact left behind that will accrue you cost that you'll find out in a bill later. So so I will now run and destroy the instance. And it's going to go through and start removing the same sort of, in the same kind of process it went before, just removing it all. To destroying the public key. So those lines that we see right here on the bottom, that's there's some language in the code that essentially, because it's in the application catalog, that you have to accept. So the code actually does that stuff for you. And now it's removing the instance itself. There we go. So that's the full life cycle from kind of beginning to end to show really the easy use, how easy it is to get kind of using FreeBSD inside of OCI, especially with Terraform. As you can tell, like that was reasonably quick for both instantiation and destruction. So so yeah, let's go back to the, I guess, to the slide deck now. And we'll pull that up. All right. So a couple more things for folks to take a peek at. There's a blog on the Ampere website, which goes into more details about kind of what I just did here. If you guys want to reread it or check it out, feel free. The Terraform module that I use, the exact example can be found in this subdirectory of the module. There's some more, some surprisingly, I was very, very pleased when I first started working with OCI. They've done a huge amount of effort to document things regarding their Terraform usage and the ability to use Terraform with their cloud. And they've actually done a really nice job with it. So yeah, it was a pleasant surprise. And you know, there's more documentation and reference architectures that can be found on that other Oracle link below. So I guess after that, I will thank everybody and open up the floor for questions if people have questions. And I guess, are they able to type questions into the
Yes, I'm looking on like IRC or in the Zoom Q&A, but so far we just don't have any questions, that's all.
That's fine. Well, I guess if we don't have any questions, then yeah, thanks guys for having me. Appreciate the time to talk about this, and yeah, hope everybody has the rest of a great virtual summit.
Okay, thank you very much, Peter. So, oh, I guess we actually had a question just pop up.
Yeah,
And I can tell you on, I mean, if I get my window to work, I can tell you that on IRC, there was lots of envy of having that many cores. I'll put it that way.
Oh, I can. So my background it is in OpenStack, and spent 10 years working on OpenStack. 5.5 of it I spent working for Microsoft on OpenStack, and I ran, during my time at Microsoft, I ran the largest continuous integration infrastructure in all of OpenStack. I had 38 racks of gear. I got to stand up an OpenStack while I was at here at Ampere over the pandemic, that within a single rack, I had more cores than the 38 racks of gear I had while I was working for Microsoft. So I can promise you, it makes me giddy when I see that. Essentially, well, there's no threads. So I saw the processor that is in the OCI is the Ampere Ultra. We have a single thread per core. So we don't do hyperthreading. So essentially, yeah, you don't have to worry about how many threads per core. You can just pass them along to each core. So unlike whereas you get in other clouds, if you're using hyperthreads, you believe they give you 2 virtual cores to get to a full core. With us, you actually get the whole core. So from a performance perspective, essentially, you know, it gives the what is the advantage? Yeah, you're right. There is an advantage and something more reliable about having a single thread per core. From a cloud provider perspective, it eliminates the noisy neighbor, where if you can imagine, there's you know, contention for the core, and potentially you know, you can get I guess, you know, like feedback from because of that contention can cause unreliability. The additional kind of piece of reliability from our perspective is that because you're getting a single thread per core, and that single core has a consistent frequency, whereas in a hyperthreaded environment, you have multiple, essentially the frequency changes because of the contention for the core itself. We can deliver basically a better usage pattern and more reliable usage pattern, and a consistently basically of that core. So we call it predictability. So you know, you can predict the performance you're going to get because it's consistent. So yeah, that's what I would say.
And then I have a couple questions from IRC. And you could just answer them the best that you would like to answer. The first question is, how far would you trust Oracle?
All right. No, that's a great question. And as Ed knows, because when we first met and I first proposed the idea of this, I've been working in open source for 25 years. I started working professionally in open source for a company called Zimian that created GNOME. And I can tell you that, you know, Oracle as a company does not, you know, they've done some stuff historically that isn't always very open source friendly, right? So, you know, from my perspective, it's been a challenge at times when working with open source projects to try to get over that barrier. Now, what I can tell you is this is a service company, right? So this isn't the same, I guess, the same people that had done, that I guess were involved in some of those things historically in the past. The mentality of the folks operating the cloud is a little bit different because they are a service provider providing infrastructure. So, and they're well aware of kind of the history and the challenges that they have from that standpoint. So I can tell you, I've been using this for 2 years now, and I've had extreme reliability with it. I actually, because of my tenure in OpenStack, I know some of the individuals who I used to work with on OpenStack went to work for Oracle and helped them build this iteration of the cloud. So from that perspective, I have a little bit of insight into that, and I trust. Well, I trust those individuals from my time being spent doing engineering with them. So yeah, I would say I trust it. I think in terms of the other cloud providers, they obviously are a little bit newer to the game from that perspective, but they're also very hungry, and they're looking to differentiate themselves explicitly, in some cases through the offering that they have with the Ampere chips from a ARM native compute perspective. And I know that they're very in tune in terms of trying to build a great user experience of their cloud, which I can promise you I was pleasantly surprised at how easy it was to use, especially being a Terraform fan and wanting to do everything in Terraform across cloud providers. So they have spent a significant amount of time both integrating Terraform usage into their like web portal and user experience, I think they are a trustworthy cloud provider from that standpoint. I'm sure people will have other opinions, but as I said, I can understand the position, especially having worked in open source and looking at their history, that some folks might be wary. And in all cases, I will say that the different projects that I've worked with have all seemed to have a pleasant experience with working both with the OCI team as well as with using Oracle's cloud. So.
Okay, and I know Ed actually spoke up on IRC while you were answering and said that in his experience, the OCI team has been great to work with. So another question I had, this is partly in jest, I want to quote it correctly. Is there such a thing as enough cores?
Well, no, right? Because the more dense compute, the more and the more efficient that compute is, the more we can fit into the data center. So I'm in New England. I live in the Metro Boston area, and my background is in part in the telecommunications industry. And I can promise you, we have buildings here that are never going to go away. And those buildings aren't going to get more electricity into them and aren't going to get more racks. So from that perspective, being able to have high density compute allows for further usage of that infrastructure without having to increase capital investment. So yeah, I think more cores is always going to be better. And in fact, Ampere, as we showed already with the 80 core and our 128 core, I can promise you the next chip that is in our horizon will have more cores. So yeah, we want to lead the industry in core density and continue to do that for the foreseeable future. And then I'll answer, are there some low-hanging fruit missing for FreeBSD and OCI? Yeah, the things that I've noticed so far, maybe a little bit of, there's a couple things, especially on the Cloud Init side, maybe on the logging side, that need to be cleaned up for parity with how Cloud Init logs its output and execution during first instance boot. Right now, as you saw in the demo, it was all primarily all the output was going straight to messages. In other distributions, those get broken out into sublog files, which makes it a little bit easier for reading stuff. But so far so good. I have to say, it's worked. The guys that have been working on it have done a great job. And it works like to me, it has parity from Linux from that perspective in terms of how it's used and its ability to be used and consumed. So the functionality for the Cloud Init pieces that allow you to automate are there. So it's just a matter of, I think, of a little bit of nuance or a little more, maybe a little bit of polish in some fringe corners of that sort of stuff to make it I guess see a completely with parity for Linux hosts. But that's the big one. And then the other piece obviously is bare metal. I know there were some technical issues that arose, and I believe those are all they've been worked on. I think some of them are just waiting for the code to actually make it into release. But once there's bare metal available, once the bare metal stuff is fully functional, then you'll be able to essentially, in the same way I stood up instances, a 4-core instance here, you'll be able to do that with bare metal instances using FreeBSD on OCI. And in that case, you can get up to, I believe it's 160 cores, much like the Mount Collins that I mentioned earlier. So two socket configuration with 80 cores apiece. So, and that can do some significant computing. I think those are the two areas that I know of off the top of my head that could use a little more polish.
So another question we had from IRC is, I think this is specific to Ampere. Do you have any quality of service guarantees? Let me state this: quality of service guarantees for shared caches and main memory.
Yeah, that I'm not sure of off the top of my head. And I would have to go back and do that. I know in our Ultra processor, we do have an L3 cache that's not present on the Ultra Max because we remove it for more die space to get higher density compute. But in terms of specifics for SLAs, I'd have to look. I'm not sure off the top of my head.
Okay. And then I have one last question, I think, we have one on Zoom too, but I have one more question from IRC, and then I think there's one left in the Zoom Q&A. The IRC question is, do you have any kind of feel or judgment or opinion on the risk of maybe vendor lock-in for clouds if you're using ARM systems?
Well, it's funny. In the case, the only right now, so where the ARM instances that are found in OCI, in Azure, as well as in GCE, and then obviously if you're using, Amazon, they have their own chip that they curate and produce, right? The Graviton line. So, I know, from a personal perspective, Amazon has made a lot of moves in the last year. If you read publicly what they did around, solidifying their kind of position on the ARM stuff, their movement with Amazon Linux, moving from a CentOS base to a Fedora base was primarily done so that they could ingest the userland changes and kernel changes that are available for ARM, that are going upstream for ARM faster. So, and I would say that, from a vendor lock-in perspective, I think there's diversity in the ecosystem. There's other folks, other cloud providers in Asia that are also, producing ARM chips for their clouds as well as consuming ours. So I would say there's right now a healthy ecosystem that has competition within the ARM processor space. But I'm a little biased from where I sit, and I'd like all of you to use Ampere processors anyway, because we do have I do feel we have a performance advantage over the competition that's out there. We put a lot of effort into and focus on ensuring that we have a highly optimized cores, as well as highly performant processor and reference platform. So yeah, I think a lot of the times when I think of like an Amazon's compute, it's usually it's usually for what I would call lowest common denominator, right? Like it's a general service platform. Hold on, I'll answer the first one first. Does OCI still support ARM v7 jails, or are those cores already 64-bit only? I do not know if they support ARM v7 jails. Our cores are ARM v8. So the ones that are found in OCI today that I know of are Ampere cores. I'm not sure.
I guess the question would be, can they run like existing 32-bit binaries?
Ooh, that's a good question. I know. Yeah, I think it depends. I know Debian, for example, was having some issues with running 32-bit binaries on the ultras, but they found some workarounds to help enable that. I don't know all the specifics, and I think Ed or one of the folks on the FreeBSD team might know better for FreeBSD specifically. And then I have to be honest, I don't know enough about the Qualcomm Nuvia stuff, or I'm not a lawyer to comment on lawsuits, I guess surrounding the IP of that. So
that's probably wise.
Yeah.
I think we're getting close to the end of our slot, and the pace of questions on IRC has slowed down, so we might be at the end of questions. But really, thank you for your talk. And actually, some of the commentary I did get on IRC was thank you for the direct answers to perhaps some not as tactful questions.
That's okay. I'm like I said, I've been in open source for a while, and I'm usually one of the people asking those same questions, so I can appreciate it. And it's always, I'll always try to answer them as directly and honestly as I possibly can, because I know, a lot of us put our trust in open source software, and we build, relationships with folks over years. Working on that stuff, and those are just as important as friendships and other things in my I guess thought pattern. So yeah, thanks for asking the questions. I appreciate it.
No worries. Thanks again, Peter.
Anyway, thank you very much.
Okay, so that was our last talk for today. I'm gonna set it up so we can get ready for our kind of the end of our summit. So I wanted to thank everyone for attending and for asking good questions and listening to our speakers. I also wanted to thank all of our speakers for taking the time to come up with a talk and spend time giving your talk. I wanted to also thank all the folks on the team who helped make the summit possible. I mentioned them at the opening yesterday, but Anne and Deb and Lauren, Drew and Ed and Joseph have all been really helpful in recruiting talks and working with speakers and setting up tech rehearsals and so forth. So there's a lot of work that goes on behind the scenes to help these summits pull off. We do have several upcoming events that we're excited about, and these are the best part about all the events on the slide that I'm looking at is that all of these events are in person. And I mentioned a couple of times that several of us were able to go to Vienna in September, 2 months ago, and that was really great to see folks again in person. So I'm looking forward to having more in-person events coming up this year. So you can see we have FOSDEM in February that will have a BSD dev room, I'm sure. Hiroki mentioned earlier this morning about Asia BSD Con, that will be at the end of March, and he said he will send out an announcement tomorrow, or I think he said within 24 hours. So tomorrow he will send out a mail announcing that one. Scale is coming up in March in Pasadena. And then many of us will be at BSDCan in Ottawa this in May. I think that was just announced on Twitter like yesterday, and I think they're still going to be sending out the mail about that one soon with a call for papers. So looking forward to seeing folks. I mean, I know many of us are looking forward to seeing folks at these conferences that are coming up. And then lastly, tell us what you think, how this summit went. We always value your feedback for shaping how we do events in the future and how we adjust things like scheduling and so forth. So there's a link to the survey. We're going to also drop it in IRC and Slack after the call is over. But please take a few minutes and fill it out. It's only a couple of questions. Well, more than 2. So maybe it's more like 4 or 5, but it won't take very long, just a couple of minutes, and it really helps us out. So please take time to do that. But thank you for joining us, and we look forward to seeing you in the future at a Dev Summit, most likely in person, which would be the best part. So thank you all again, and we'll see